Okay, I want you to picture something for a second. What if one single AI could play a video game, have a conversation with you, describe a photo, and then, without any changes at all, control a real-life robot arm? I know, it sounds like something straight out of science fiction, right? But it's very real, and we're going to break down exactly how it works today. Let's get into it.
So, meet Gato. This is a single, generalist agent from DeepMind. And the keywords here are single agent. This is not a bunch of different AIs cobbled together. No, it's one neural network with one set of weights that can pull off hundreds of completely different tasks. So how on earth is that even possible?
Before we dive into the how, let's just take a moment to appreciate the sheer range of what Gato can actually do. Because the results are, well, they're pretty staggering.
So on one hand, Gato can totally live in the digital world. It can hop into classic Atari games and actually achieve better than human scores in a whole bunch of them. And then, on the other hand, it can just chat. You can ask it questions and it'll respond, pretty much like any modern chatbot you've used.
But this is where things get really wild. Gato's abilities are not just stuck behind a screen. That exact same network can send out the commands to control this physical robot arm, telling it to see blocks, pick them up, and stack them. This jump from the digital to the physical world, that is a huge deal.
Right, so this leads to the big question. How does this actually work? I mean, playing a video game feels completely different from stacking a block or writing a sentence. So what's the common thread here? What's the secret sauce that lets one AI learn it all?
Well, the secret, it lies in creating a kind of universal language that the AI can understand. It's a way to translate every possible action, every observation, into one single consistent format. And that secret is a process called tokenization. You can think of it like a universal translator for data. It doesn't matter what it is, the word cat, a single pixel from an image, the up button on a joystick, or the exact amount of force a robot joint needs, Gato converts every single one of those things into a digital token, which is basically just a number.
So what's really cool about this diagram is how it shows you what's happening. Everything, text, images, actions, it all gets flattened into one long sequence of these tokens. So, as far as Gato is concerned, there's no real difference between the tokens that make up a question and the tokens that tell a robot arm how to stack a block. It's all just one long sentence.
So, the whole method is actually pretty simple in theory. First, you serialize the data, just line everything up in order. Then you tokenize it, turn everything into numbers. And finally, you use a transformer, the same kind of tech that powers large language models like GPT, to do one simple thing: predict the very next token in the sequence. And that next token could be the next word in a sentence or the next move in a game.
Of course, if you want a jack-of-all-trades AI, you need to give it a jack-of-all-trades education. And to learn all these skills, Gato was trained on a dataset so massive and diverse, it's honestly kind of hard to wrap your head around.
And this chart really shows you the scale we're talking about. Gato was fed over 1.5 trillion tokens of data. Now, the huge majority of that, over 85%, came from control tasks, so things like video games and robotic simulations. But that crucial other 15% or so, that was classic text and image data, which is what helps the model actually understand the world.
And all that data came from an incredible 604 different tasks. So this isn't about becoming a world champion in one thing, it's about learning the patterns that connect hundreds and hundreds of different kinds of problems.
Okay, so it learned from this huge variety of sources. But the big question remains, after all that training, how well does it actually do? Let's go ahead and check the report card.
This graph right here is really the headline result. It shows how many tasks Gato can perform at a certain skill level compared to a human expert. And the key takeaway is this: Gato hits at least 50% of an expert's score on over 450 of those 604 tasks. It might not be the absolute best in the world at any single thing, but it's impressively good at almost everything it was taught.
Look, being good in a simulation or a game is one thing, but the ultimate test for a generalist agent is how it handles the messy, unpredictable physics of the real world. So how does Gato do when it has to control an actual robot? So the researchers set up this really tough test. The robot has to stack the red block on top of the blue one. Simple enough, right? But here's the twist. The actual shapes of the blocks it's being tested with are shapes it has never, ever seen during training. This tests if it really gets the concept of stacking. And the result? A success rate of 50.2%. Now, I know what you're thinking. That's barely a coin flip. But what's so incredible about that number is that it's competitive with, and in some cases even better than, other highly specialized AI models that were trained only to do this one specific task. Gato does it while also knowing how to play Atari and caption photos. It's amazing.
So Gato basically proves that a single generalist AI is possible. But what's maybe even more exciting is what this tells us about the future.
The researchers tested different sizes of the Gato model, and they found a very clear pattern, which you can see in this graph. Just like we've seen with large language models, performance consistently gets better as you just scale up the size of the network. The biggest model they tested, at 1.2 billion parameters, performed the best, and this suggests we've really only just scratched the surface of what's possible here.
And that brings us to the core conclusion from the researchers themselves. They believe that this whole approach, tokenizing everything and training a big transformer, isn't a dead end. It's a foundation. And by simply making the model bigger, feeding it more diverse data, and giving it more computer power, we can create even more capable, useful general-purpose agents.
So this leaves us with a pretty fascinating question to chew on. We've just seen proof that a single AI can master over 600 different tasks. If the main thing holding it back is just scale, more data, more computing power, what happens next? The path to a truly generalist AI might be a lot clearer than any of us thought.